Time. It's the most relentless force in the universe. It pushes us forward, second by second, minute by minute. And no matter how much we wish, we can never go back. The glass shatters, but never unshatters. A candle burns down, but never grows tall again. A loved one says goodbye, and that moment is gone forever, or at least that's what we thought. But in a laboratory, scientists have done something extraordinary. They use a quantum computer to roll back the arrow of time by 1 second. Not in a movie, not in science fiction, but here, now. What does this mean for science, for technology, for our understanding of reality itself? And maybe the biggest question of all, is this the first step toward controlling time? Let's start with something simple. Why does time move forward? Why do we grow older instead of younger? Why do buildings collapse but never rebuild themselves? It all comes down to one idea: entropy. Entropy is disorder. The universe naturally drifts from order into chaos. A brand new deck of cards, perfectly stacked, will shuffle into randomness. A hot cup of coffee will cool down, never heat itself back up. Entropy always increases. That's why time feels like a one-way street. Forward. This is called the arrow of time. It's one of the deepest laws of physics. And for thousands of years, humans have lived under its rule. But here's the strange part. If you zoom in far enough to atoms, particles, and qubits, the fundamental equations don't care. They work just as well going forward as they do going backward. In theory, nothing stops time from running in reverse. But in practice, it never does. Or at least, it never did until now. So how did scientists pull this off? Let's go inside the quantum computer. Quantum computers don't use bits like our laptops. They use qubits. A regular bit is either 0 or 1. But a qubit? It can be 0 and 1 at the same time. Thanks to quantum superposition. This makes quantum computers incredibly powerful, but also fragile. Qubits are like spinning coins. A tiny nudge from the outside world, and they collapse. Errors creep in constantly. So scientists wondered, could they design an experiment to deliberately rewind a qubit state? Here's what they did. They prepared a group of qubits in a known, ordered state. They let them evolve forward naturally for 1 second. Then they applied a sequence of operations, carefully calculated to reverse that evolution. Think of it like pressing play, then rewind. And when they measured the system again, the qubits had returned almost exactly to where they started. For 1 second, time inside that quantum computer went backward. Now, what does that really mean? Let's make it relatable. Imagine shuffling a deck of cards. Normally, it gets messier and messier. The odds of it reordering itself perfectly are astronomically small. But in this experiment, it's as if someone hit rewind and the deck unshuffled itself. Or picture cream swirling into coffee. Once it mixes, you can't separate it again. But these scientists, in their tiny system of qubits, managed to make the cream jump back out. It wasn't coffee, it wasn't cards, but it was the fundamental building blocks of matter. And that makes this experiment historic. Okay, but let's be real. What's the point? Does this mean we can build a time machine? Not quite, but here's why this matters. 1. Quantum error correction. Quantum computers are plagued with mistakes. If we can reverse certain operations, even briefly, we might undo those mistakes. That's huge. It could bring us closer to practical, world-changing quantum machines. 2. Testing the foundations of physics. We've always wondered, why does time move forward? Is entropy truly unbreakable? This experiment doesn't overturn those laws, but it lets us probe them in ways we never could before. 3. Human imagination. For thousands of years, humans dreamed of controlling time. From myths of time gods to science fiction movies, it was always fantasy. But now it's real science. Even if just for 1 second, the arrow of time bent. Now here's the reality check. The experiment only worked in a handful of qubits. Scaling that up to something as complex as you, me, or even a grain of sand, impossible. Why? Because the world is noisy. Billions of particles interact every second. To reverse that, you need total control of the entire universe. And even then, you'd still face entropy. The second law of thermodynamics wasn't broken. The lab's machines consumed energy. They generated more disorder outside the system. So the universe still marched forward, even while a tiny piece ran in reverse. This wasn't a time machine. It was more like a scientific magic trick, but a trick that reveals something very real about the deepest workings of reality. And yet this changes everything, because for the first time, we've proven that time isn't as rigid as we think. We've taken the unstoppable arrow and bent it, if only for a heartbeat. It's a reminder that our universe still holds mysteries, that the laws we take for granted aren't as unshakable as they appear. It makes us ask, if we can bend time for 1 second, could we bend it for a minute, an hour, a lifetime? Could we one day record time, rewind it, and replay it like a movie? Or is time not something to be controlled, but something to be understood? Either way, we are standing at the edge of discovery. For centuries, we've been prisoners of time, but maybe, just maybe, we're learning how to pick the lock. So no, scientists haven't built a time machine, but they have proven something extraordinary, that even the most fundamental force we know, time itself, can be bent, and that's a story worth remembering. If you found this as mind-blowing as I did, hit like, subscribe, and share this video, because this is just the beginning. And I'll leave you with this question. If you could rewind 1 second of your life, which moment would you choose? Drop your answer in the comments. And together, let's imagine what the future might hold. Movie camera fade out. A glowing clock rewinds 1 second, then freezes. Title card. The future starts here.